Hello and welcome everyone. My name is Kelly here with Esri and I'd like to thank you for joining us on our webinar today. So today we're going to be talking about ArcGIS Velocity, and with that I'll go ahead and turn it over to our first presenter today, Jennifer Dillon.
Thanks, Kelly, and thank you everyone for sharing a little bit of your time with us today. As Kelly mentioned, I'm Jennifer Dillon. I am an Esri account executive on the Federal Public Safety team. Also here with you is Suzanne Foss, Velocity Product Manager, and Kevin Armstrong, Senior Solution Engineer, who'll be providing the demonstrations on ArcGIS Velocity. You know, these days it seems that sensors are just about everywhere. Sensors are deployed across government assets, whether in national parks, warfighting domains, or highways, you name it. Sensors are continuously generating and collecting data, providing great opportunity to capture that data in real time. Today, we're excited to show you how real-time data can provide government agencies powerful new insights into things like operations efficiency and infrastructure security. To get started, let's take a look first at some of the trends that we're seeing in real-time data across the national government landscape. One of the biggest trends we're seeing in real-time data use is in UAS detection and threat assessment. Leveraging real-time data for UAS sightings can be extremely helpful for some mission owners, particularly for those who are looking to provide deeper security capabilities, such as securing an airport by monitoring flight paths or assessing potential UAS threats to other modes of transportation, by visualizing and then identifying the trends through both historical and live feed data. An example of this, and you'll get to see this in the demo later on, is what Velocity can do with White Fox drone detection data. Here, you'll see the ability to do things such as summarize flights by jurisdiction or timestamp, and see how Velocity brilliantly manages the capture of real-time feeds, allowing you to then pull those data feeds together with other data sources, such as data that's been gathered over time. You can then apply analysis and then visualize the results, which you can immediately put to use. Other UAS detection workflows include security for large special events and the protection of critical infrastructure. Each of these workflows pose a complex preparation effort, and when real-time data is captured, analyzed, and used effectively, the result is significantly strengthened security posture. Still, other applications of real-time data and analysis can be seen in what we call intelligent transportation, which essentially applies to multiple modes of transportation. Herein lies the ability to analyze real-time data streams pulled in through sensors, be it vehicles or aircrafts or vessels or other sensors, and then analyze, assess, and alert on things like speed of travel, current conditions, weather or traffic congestion, or anything that might be relevant to causation, for example, of an incident or an accident requiring federal level investigation. And finally, we've observed the need for real-time data in helping to secure our nation's critical infrastructure and supply chain workflows. From awareness of facility status to disruption in a supply chain resulting from asset tracking as conditions are monitored throughout the supply chain process. When harnessed effectively, real-time data helps us understand what can and is impacting operations, but we need to effectively visualize it to get there. And not only visualize, but apply capabilities through analysis and then allowing us to further inform the next steps. There are so many more use cases organizations can use in their work. I'm going to pass things over to Suzanne to tell you more. Suzanne?
Thanks very much, Jen. So all of these examples that Jen's been providing are indicative of the fact that there's a wide variety of geospatial use cases from sensor data that comes from the Internet of Things. It's been estimated that 80% or more of sensor data has a location component. And there's use cases for this data that are, as you've seen from Jen's examples, applicable to national government, but also use cases that are applicable across many other industries as well. For example, real-time data from sensors about employee locations is increasingly available. Sometimes this comes from wearable devices. Sometimes this comes from an application on an employee's phone collecting their position. And a lot of organizations, national government agencies and others as well, want to combine this information on personnel tracks with data from the immediate environment around them to help keep them safe, and also to gain insight from their movement to help optimize their work and allocation. And that concept of resource optimization in terms of allocating resources and fleets to different areas has been an interest of organizations for years with real-time data from assets. And then there's also what we might generally refer to as infrastructure protection or threat monitoring. And this goes back to what Jen was saying about critical infrastructure and supply chain. A lot of organizations want to leverage contextual data to protect facilities or network infrastructure or other things that they care about. And this often has to do with monitoring weather hazards, or at least historically that's been a big trend. But increasingly there's other kinds of real-time threat data streams available. And looking at any of those things in conjunction in real time with the infrastructure that you care about can be important. There's also geospatial Internet of Things use cases that are more specific to different industries. So for example, in the utility space, there's SCADA integration and operations monitoring. In the agricultural and environmental markets, there's crop and air quality monitoring. And in transportation, even beyond intelligent transportation use cases for the national government, broadly local governments are interested in intelligent transportation as well, bringing in data that's coming in from connected vehicles through roadway sensor deployments, and being able to mine that data, understand traffic patterns at levels that they've never been able to before, and so on. So the broad list of use cases for Internet of Things data is really very wide and varied. And ArcGIS Velocity has been designed specifically to provide a framework for these kinds of use cases. ArcGIS Velocity is a new capability that extends Esri's geospatial cloud, ArcGIS Online, with real-time and big data functionality. ArcGIS Online, of course, is Esri's flagship cloud-based mapping system. ArcGIS Velocity extends ArcGIS Online in a couple key ways. The first way is bringing the ability, an out-of-the-box ability to ingest real-time sensor data. You can configure out-of-the-box included connectors to bring in data from IoT platforms and third-party APIs. And then it's also an end-to-end system for analysis, supporting analyzing data in real time, in near real time by scheduling advanced analytics to run on a regular basis, and then also analyzing data over time historically to look at broader patterns. And thirdly, you can take immediate action as a result of your analysis with this tool. So you can send notifications or trigger downstream processes based on your findings. Within the ArcGIS system, ArcGIS Velocity is part of our real-time visualization and analytics capability. In many ways, it's a sibling product to what we have in ArcGIS Enterprise today. In ArcGIS Enterprise, you might be familiar with server roles like GeoEvent server, which allows you to bring in real-time data and do incident detection in real time, and GeoAnalytics server, which allows you to process high volumes of collected information over time. ArcGIS Velocity includes both of those capabilities in a single solution, and currently as a capability of ArcGIS Online. It's cloud native. It can also scale to higher velocities and volumes, and it provides easier configurability without necessarily having to be an IT administrator. Right now, ArcGIS Velocity is a capability of ArcGIS Online, but it is also on the roadmap to bring ArcGIS Velocity as a solution that can be run in an on-premises environment and integrated with ArcGIS Enterprise. So what we'll do next is talk a little bit about how it works and then really dive in with a demonstration to give you guys a sense of how these pieces can work together with regard to drone counter monitoring. So a little bit of a conceptual architecture with ArcGIS Velocity, just to kind of paint a picture for you all. ArcGIS Velocity you can think of it as sitting on the edge of Esri's geospatial cloud. And it isn't an Internet of Things platform, but it complements Internet of Things platforms by enabling you to bring that sensor data into ArcGIS and perform geospatial reasoning against that data. So as sensors are deployed out in the field today, they're increasingly being onboarded and connected up to IoT cloud frameworks. Azure, AWS, and Google have solutions for being able to onboard and connect up devices. ArcGIS Velocity can subscribe to or query many of these IoT platforms directly without requiring developer level integration. It's already included. Sensors can also drive data directly to ArcGIS Velocity in some cases. That's more common if the sensor is essentially the application on someone's phone and it's driving information over the internet to Velocity. Within ArcGIS Velocity, there are user configuration abilities in three main ways. Feed items allow users to receive sensor inputs. They're those user configurable components to make connections to real-time data. And then feeds can be used in real-time analytics to perform geofencing, incident detection, data enrichment against that information, and also trigger alerts and actions. You can also store data over time with a real-time analytic with data retention policies that you can choose from. And with that data that you store over time, you can run big data analytics against those data lakes, if you will. Both of those types of analytics, of course, can produce output data in the form of ArcGIS layers. And those layers can be used in ArcGIS applications like dashboards for ArcGIS. They can be used in custom JavaScript and other APIs, and they can be used in desktop tools as well. So now to step a little bit more into an actual use case from these basic fundamentals, I'm going to turn it over to Kevin, who's going to walk us through a solution for counter-drone UAS monitoring that uses both elements of the ArcGIS platform and ArcGIS Velocity to solve these use cases. Kevin?
Okay, thank you, Suzanne. What I'd like to show you today is how ArcGIS Velocity can be used to enable a visualization and analysis of real-time data. So in this dashboard here, what we're seeing are data on active UAS flights in the Los Angeles area. And this is provided by our partner, White Fox. So to understand a little more about this data, let's go ahead and take a closer look at one of these locations. So as you can see here, for most flights, we get information obviously about the location of the UAS. We can see also the location of the pilot. And this, as long as that flight is active, we can visualize both of these features in real time. We can see other features like the assigned flight ID and the altitude of the flight. And we can also look at the history of the flight itself, so we can see previous locations for this particular flight. And we can do things like visualize the altitude of each of those observations over time. So this gives us a really quick and easy way to view the information that's coming to us in real time. The other thing we can do in this dashboard is just summarize all the data that we're seeing. So we can look at the chart of detections by hour, and we can see the trend throughout the day as more and more flights take place. We can visualize those. We can also see the flights in a list and sort that from the most recent in the day and on down to ones that we've detected earlier in the day. So this dashboard is really just a configurable viewer, but ArcGIS Velocity is kind of the engine behind the scenes that's bringing the data to this dashboard. So let's take a look at Velocity and see how we're doing this. So this is within ArcGIS Velocity now. And as you can see here, we've created a real-time feed for receiving the White Fox data. So to create a feed in Velocity, all you have to do is go into the Create Feed window, and this allows you to connect to a lot of different sorts of data sets. So if you want to pull in data from ArcGIS, like if you had a tracking layer using our tracker app, or you wanted to read data from your GIS, if you wanted to connect to a cloud service like Azure or AWS or Cisco, or if you just want to receive data over the web. In this case, for White Fox, we're just using our out-of-the-box HTTP poller to connect to their API and bring data into Velocity. And Velocity also allows us to monitor that connection. So once we've created this feed and data starts flowing in from White Fox, we can monitor that feed and look at the volume of events coming in over the last hour or day or week. And we can see the trends in the data. So as we see times of the day where we have a lot of detections, we can see the spikes in activity over time. So what I'd like to do is just go back to the dashboard and explain a little bit about what we can do with this real-time feed of UAS flights. So there's certain situations where a flight may be in violation of, an established flight rule, or maybe pose a security risk to critical infrastructure. And the agencies in charge of these assets really have a duty to protect the people, places, and things that they manage. So in this case, we need a way to detect violations and potential security risks. So let me turn on a layer here of critical facilities that we've created. And what we'd like to do is be able to monitor where flights are occurring around these facilities. So just by turning that layer on, we can see, how close these flights are in relation to these sites, and that's pretty powerful. But what we want to do is use ArcGIS Velocity to automatically detect flights that could be of concern to us. So what we're doing behind the scenes is using Velocity to find the closest facility to all of these flights that are taking place. So if I zoom in here up to site number 2, we can see behind the scenes, we're using ArcGIS Velocity to link each flight to its closest facility. And if I click on any one of these lines, we'll see that for this flight, we get the flight ID, the facility that's closest to it, the observer who's stationed there, and the distance of that flight from the facility itself. So this just allows us to go in here and automatically detect flights that are occurring near our facilities. And we can also view detections by site. So since we're tagging each flight with the facility that it's nearest, we can look at activity throughout the day and see which one of our sites are seeing the most activity based on this analysis. So how is all this happening? So let's go back to ArcGIS Velocity and see what we're doing here to enable this dashboard. So this is a real-time analytic that's bringing in the White Fox feed that we showed earlier, and we're doing some spatial analysis around this. So once we create the feed to connect to that data from White Fox, we're going to perform some spatial analysis. So we're using data from the Census Bureau here, populated place names. So when a point comes in, we're automatically assigning it a place name, like West Hollywood or Torrance. And then we're doing the analysis that we showed in the dashboard. We're finding the closest facility from our layer that we're using in ArcGIS of our critical facilities, and we're able to find the facility and the distance to that facility. And then the next thing we're doing is we're looking for another type of incident, a flight violation. So we're taking an FAA map, and you can look at that map here. This is a map the FAA puts out showing areas where you're required to have authorization to fly near airports. And each of these grids has an altitude where you're most likely to get authorizations. So if you're above a certain altitude here, it's unlikely that you're authorized to fly at this altitude. So we may have a potential violation. So we can use that authoritative data from the FAA to compare it with the altitude that we're getting from White Fox of the UAS flight, and compare the two and see if there's any potential violation. And then the next part of this analytic is creating outputs to power our dashboard. Now, since most of the flights contain the latitude and longitude of the pilot, we can not only create a point showing the location of where the pilot is in real time, but we can use that location along with the latitude and longitude of the flight and create a line to link the pilot to the actual UAS that they're flying. And the same goes for our critical facilities. We know the latitude and longitude of our facility as well as the latitude and longitude of the UAS, so we can create a line linking the two together as well. And then we're also creating a real-time feed of the actual UAS flights, which we saw earlier, and we're storing all the observations over time that we see come in throughout the day and weeks and months. So we're also creating that historical layer. So let's go back to our dashboard here just to reinforce what we showed. And let's just zoom in a tad, and you can see what information we're getting. So we have our site, and each UAS flight We're able to obviously visualize its location, draw a line linking the two, and calculate the distance. But we can also see the location of the pilot in relation to that flight as well, and we can see the distance between them. So besides just surfacing a location on a dashboard and showing the real-time feed of flights that are going on, the other thing we can use Velocity for is to drive action at our facilities. So the other thing we're doing with Velocity here is each detection, each new flight that occurs, we're able to look at its distance from the facility, we're already calculating that, and use that information to send an email to that site if it meets certain logic. So in this case, we're filtering only flights that occur within 1 mile of our facility. And if we do detect that, then we will take some information from the flight and create a link to a Survey 123 form and to ArcGIS Navigator to supply some information to our security officer at the site and send that information in an email. So I'm going to bring my phone over here and show you what that email looks like. So I can click on this email and I can get directions to the pilot. So if I just click that link, it'll automatically launch ArcGIS Navigator and provide me with driving directions from my site to the actual pilot location. And it also provides me a link and populates some of the flight information into a Survey 123 form. So I see the site ID, the flight, the location of the pilot, and then I can go out and look for the pilot and fill out this form so that I can detail the action that we've taken. Did I find the pilot, yes or no? If I did, I can fill out information about the pilot. And same thing with the UAS. I can fill out information about manufacturer, model, take a photo of it. And if I do have jurisdiction or enforcement authority to take action, I can detail what action we've taken with that particular incident. So this isn't just populating data on the dashboard and showing real-time analysis. We're also driving action out in the field by sending information, in this case through an email, to our site so that they can take action with it. With that, we'll go back to you, Suzanne.
Thanks so much, Kevin. All right, so what you saw a couple things in that demonstration, and I just wanted to reinforce a few points as they relate to ArcGIS Velocity. One of the components of the dashboard and the different use cases that Kevin was showcasing involved creating a feed using ArcGIS Velocity. Feeds in ArcGIS Velocity are essentially the first step in leveraging sensor data, which is just accessing it and being able to bring it in. And this is a part of the solution because with the thousands of sensors on the market today, it's often challenging for organizations to be able to connect data. And when they do, or when it's available from the original vendor, sometimes it's siloed in a specific application, which it provides important visuals, but doesn't necessarily allow you to integrate it with other enterprise data. In Velocity, you can reach out to different APIs, different cloud IoT platforms, and bring data in a guided workflow so that you can configure the data schema, configure the connectivity to that data resource, and then basically publish a hosted continuous service that ingests that data continuously and makes it available for visualization. Feeds behave like a stream layer in an ArcGIS web map, if you're familiar with stream layers. Basically, it's based on WebSocket technology, so that as data arrives in real time from the resource that ArcGIS is connected to, that information will be pushed onto the map immediately. So feeds, in a nutshell, are both system integration and situational awareness, but configured in minutes without writing any code. And then bringing data in with feeds is just the first step. So one of the first things Kevin showed was the drone positions on the dashboard, and that's possible simply by just creating a feed. You can add the visualization to a dashboard, but with real-time analysis, you can immediately put data to use. So a feed is the input to a real-time analytic, and real-time analytics can be used to transform, enrich, and detect different kinds of incidents. As you saw with Kevin's example, very flexible model building capability that let you combine tools and take different kinds of action. There's fundamentally 3 different types of action you can take. You can store sensor observations over time to a feature layer. So Kevin was storing the drone positions over time. That's how the dashboard was able to show the variation in the flight altitude over time, because the hosted cloud service is collecting that information. But you can also send notifications and alerts. And obviously Kevin showed that with regard to having certain conditions fire an email alert that could be picked up by an operator in the field and then acted upon. But thirdly, you can also trigger behavior in third-party systems using real-time analytics. So in addition to input connectors, if you will, to bring in data, there's also output connectors. So for example, you could send data in a formatted message to another API through an HTTP command, or you could route data to an external Kafka broker if you needed to have data accessed by another system after the geospatial analysis that's been performed. Real-time analytics fundamentally provide processing horsepower to tracking and sensor workflows. Fundamentally, they work against feeds. They process each message from a feed continuously as it arrives, and they can leverage static data sources from your enterprise as well to serve as geofences or enrichment data. You combine different tools together in a visual programming interface with these real-time analytics, so there's, again, no need to write any code to configure a monitoring process that's specific to your workflows. Overall, real-time analytics are useful when your decision timeline is operational, when you need to know about something and you want to take action immediately. And then beyond real-time visualization and analysis, you can also work with data that you store over time. So real-time analytics can store data to a feature layer, and you can control the data retention and other settings of how that data is stored. But as data arrives in real time, these historical data sets can grow to large volumes very quickly. So for example, even data that's coming in at 100 events a second, which might not seem very fast, that grows to 9 million features in a day. And I'm sure many of you are dealing with large voluminous data sets that can be created from IoT systems. Because this data can grow so quickly, ArcGIS Velocity is designed to grow with you. So that's where these big data analytics come into play. These big data analytics can process that information for trends, for patterns, and we'll see that in just a moment. And one of the key things here is that this is, if you will, an automation engine. Not necessarily, there's plenty of tools in ArcGIS as well for exploring these data sets, but as you decide upon a workflow and an analysis that needs to be repeated on a regular basis, these big data analytics can allow you to do that. So they can be scheduled to run in near real time, as well as just running analysis on data over time. And so with that, just to make this a little bit more real for you, we're also going to go back into a demonstration, and Kevin's going to show how a big data analytic can work on the collected drone data for the purposes of surveillance analysis.
Okay, thank you, Suzanne. So we showed you the real-time feed and locations of flights occurring today in the dashboard. But what I also want to show you is the location data that we're storing over time. So if I turn off all the current locations, you can see the cumulative data that we're storing underneath the scenes here. So this layer here is all the observations we've received over 2 to 3 weeks of data, and Velocity is writing those out and storing those as time goes by, accumulating all this data for us, and we're able to easily zoom in and see the information. It's binned for us so we can count and see how many observations are within each area. So it kind of gives us a hotspot map showing all that information. So there's a lot of information here, and what we'd like to do is work with all this data. So I'm going to go over and switch back to Velocity, and here we're looking at a big data analytic. So we obviously have showed the real-time feed, how you can deal with data as it comes in instantaneously, but you can also create what are called big data analytics that look at very large data sets. So in this case, I'm taking we have probably over 160,000 flight locations, and I've constructed a big data analytic to allow us to I'm using the Find Dwell Locations tool to find information in each of those flight logs to where a flight may be hovering near an area for a certain duration that matters to me. So all these tools can be found up here along the top. I can easily select from multiple tools to allow me to bring data in and do some really finite analysis on the data itself. So I can drag this Dwell Locations tool in. I'm looking for locations where a drone has hovered for more than 5 minutes in the same location. And then I take those locations and I'm calculating the distance to all of our facilities from those hover locations, and I'm only returning the locations where a drone has hovered within, for more than 5 minutes, that's within a half mile of a facility that I care about. Because this could be a potential case where maybe they're doing their surveillance or someone's filming a location they shouldn't. So this big data analytic, I can take all that information, crunch it all, and once I come up with that tradecraft to really tease out the information, get that needle in the haystack that I want out of this data, I can schedule this analytic to run either once, or I can schedule it to run maybe once every few minutes or hours every day, and just save that information, have it running all the time, doing that analysis for me to detect that information I'm looking for. So this output we've put into a simple dashboard. So you can see here, we're actively collecting. This is that cumulative layer, so that gridded layer that we saw. There's 167,000 total locations that we've received over the last couple weeks, and this is growing every second, every minute. We're receiving more information, and those locations occur over 4,275 flights. So each flight has multiple locations. So what our big data analytic is able to do for us is to look at all 167,000 locations and tease out. We found 8 potential instances where a drone has hovered within a half mile of an area where we have a critical facility. So we can list out those detections and see. We had one just last night around a place, around one of our sites, and we can see in this case, this was 15 hours ago, there was a drone that hovered for 11 minutes within a half mile of a place that we care about. So we can see those detections over time. We've had one a day. It's been rather infrequent, but this is really the goal of this big data analytic, is to take these large collections of data, sort through them, do some spatial analysis, help us apply some of our logic to the data, and find what we need and display that information so that we can take action on it. So this is just an overview of what big data analytics give you in ArcGIS Velocity, as well as what you can do with the real-time. Suzanne?
Thanks very much, Kevin. All right. Let's make sure we've got the slides back. Excellent. So with the big data analytics in ArcGIS Velocity, you can analyze information that you store over time. And one of the key things here, what they're aimed for, is being able to process data that grows and becomes more and more unwieldy to work with. I think in Kevin's example, it's in the order of a couple 100,000 features, but these have been these are geared and designed to run on millions, hundreds of millions of features, and they do this all in the cloud. So one of the advantages here for organizations is not having to configure and maintain on-premise Spark processing clusters and data centers. With big data analytics, you can run analysis either on feature layers that you've stored over time through ArcGIS Velocity, as Kevin was doing in this case, but they can also reach out and pull in data from cloud big data stores and locations that or data stores that might be fed from other organizational systems. So a big data analytic can load data directly from an S3 bucket or an Azure Blob Store, for example. Much like the real-time analytics, you can stitch different tools together in an overall automated process and create multiple information products at the same time on the same data. Big data analytics are useful in two different ways, of course. One way is when your decision timelines are tactical, when you need to make a decision regularly based on standard practices. For those types of circumstances, you might schedule a big data analytic to run on a regular basis. And then also when your decision timelines are strategic, you need to learn from data over time and adjust larger approaches in your operations. There's a wide variety of spatiotemporal analysis tools included in ArcGIS Velocity for these purposes. This includes tools for summarizing data, detecting different kinds of incidents and behavior, analyzing patterns, and leveraging spatial proximity. Many of these are the same tools that are available today in GeoAnalytics Server within ArcGIS Enterprise. But the toolset in ArcGIS Velocity also includes concepts from GeoEvent Server that focus on tracking and movement analysis, like calculating motion statistics, summarizing journey and trip information. So for example, separating moving entity data from where they stayed still versus where they were continuously moving, snapping data tracks to a road network, and so on. All of these tools can be used in the big data analytics, which are Spark-based parallelized processing capabilities, and tools that can run on a single message at a time can also work in a real-time analytic. Overall, within Velocity, there's extensive support for different real-time and big data systems and various data formats. These are aimed at covering major commercial IoT platforms and common real-time messaging technology. So for example, MQTT can be used as a bridge to bring in vehicle tracking data from vendors like Geotab. And an Azure or AWS IoT hub can be leveraged to access data from a SCADA system and make it available in the cloud. Polling a website, the HTTP poll connector, enables you to access different sensor vendor APIs without having to write custom integrations. So in many of these connectors, if you will, are similar to connectors that are included in GeoEvent Server today. The goal is to provide equivalent functionality and Velocity as GeoEvent Server because Velocity is a solution for ArcGIS Online, whereas GeoEvent is not. I've seen that coming in on the questions, so I just kind of wanted to raise that as well. Now, drilling in on some of the outputs, both types of analytics in ArcGIS Velocity can generate output layers for visualization of time-enabled data. And you've seen Kevin use 3 different types throughout the demonstration, so I just kind of wanted to reiterate some of those. The first type of output that I'll talk about is the stream layer. So the stream layers visualize new data right as it arrives. These are the layers that are WebSocket based. What we're looking at in this animation happens to be city buses moving around on their routes. And so this is where the information comes to the map immediately. It provides that really smooth real-time animation. And they're very useful for watch officer type of situations where you need to follow the movement of an asset closely. And then for many other kinds of data, feature layers are another output, and they visualize data once it's been stored. These are, of course, the most common layer used in the ArcGIS platform. To visualize data from feature layers in near real time, you can set a refresh interval, so you requery information every few seconds. And when you create a feature layer in ArcGIS Velocity, it also creates a special kind of map image layer, which allows you to do dynamic aggregation visualizations of high volume data. So what we're doing here is zooming in on, I think, connected car data in this case, where at a certain point, the aggregations refine and then show you the raw data when you have a reasonably low enough number of features in the view extent. And Kevin showed this example as well with the drone information. So this is a useful way as data volumes grow higher and higher to visualize the general pattern of the information that you have in your data store without necessarily having to draw each feature individually. So all 3 of these layers can be created through the analysis tasks in Velocity and used in dashboards and apps to visualize this information and improve situational awareness. And so with that, we'll go ahead and wrap up our presentation today so that we can take some questions. To reiterate, overall, ArcGIS Velocity is a fully configurable real-time and big data engine for ArcGIS Online. And there's 3 primary capabilities. Again, from a full configurability perspective. The first major capability is ingesting sensor data. Part of this is wide support for different messaging systems, data formats, and being able to handle data at different rates, so both low velocity and high velocity data. The second major focus in ArcGIS Velocity is to allow you to automate analytical processes and implement your own tradecraft on that data. And that's whether it's in fully real time in a streaming way, in near real time by composing a process that you can schedule, or just working with massive amounts of data over time. And then thirdly, the third major capability is to drive specific action based on your analysis results, such as alerting. So these capabilities in ArcGIS Velocity are all configurable using powerful and familiar spatial analysis tools, and can be applied to use cases from personnel tracking to asset monitoring to threat and infrastructure monitoring and awareness, like in the UAS monitoring use case. There's a lot of resources out there on ArcGIS Velocity for users and interested customers. It's a relatively newer capability in ArcGIS Online, so we wanted to provide you some quick references to some of the information that's out there. So check out our blogs. There's also a Learn lesson if you are getting started with ArcGIS Velocity, and a lot of technical content being added to our community on especially how you can use the different connectors to pull in different kinds of data. So thanks very much to everybody for your attention today. And at this point, we'll go ahead and spend some time focusing in on some of the questions that have been asked. So we'll go ahead and look at that now. We've been answering some questions throughout the presentation, but we just wanted to save some for the end here as well. So one question that came in, which I think might be on many folks' minds, it was about the drone data in particular, how the data was being transmitted, how the data includes the location of the pilot. These are very good questions. What we're going to do for those of you that have asked these questions is sync you up with White Fox directly so that you can get the authoritative answers from them. So we'll follow up with those folks that asked those questions afterwards. There was another question, which I think might be indicative of things that other people are wondering, which is, whether ArcGIS Velocity can help to bring data onto an ArcGIS dashboard from a database. I think in this case, the question was about stream gauge data. And the answer is most likely yes. Depending on the way that if you have your own data and you're having difficulty getting it, onto an ArcGIS map in real time or in near real time, depending on where you have that data stored and how it's accessible, it's very possible that ArcGIS Velocity would have an out-of-the-box connector to be able to either query that data if it's coming from a database, if that database has an API that allows you to submit queries and return results, then that could be something that ArcGIS Velocity connects to directly. Or if your system exposes data in some sort of real-time messaging stream, for example, making data available over an MQTT broker or a Kafka broker, for example. Let me see what some of the other questions are here. One question was, is the drone data a sensor feed from the FAA? In this case, it was not. It was from an Esri partner called White Fox. And if there are such sensor feeds available from the FAA, I can't confess to being extremely familiar with them. This one in particular was from White Fox. Another question was, can we create custom connectors for new data feeds? Or because this is online, are we limited to what is in the box and what is out of the box? And the answer is because yes, because this is a SaaS and it's part of ArcGIS Online. Much like the rest of ArcGIS Online, we would not host third-party code in Velocity to run for custom connectors. Another question people may have that this kind of gets back to is, we are on a path for FedRAMP certification to be added to ArcGIS Online's FedRAMP certification. So hosting and running third-party code would not be something that we could do and also meet security requirements at the same time. If you are looking for solutions to create custom connectors to bring in real-time data, there's probably two main approaches. One with ArcGIS Velocity, because it can connect to a lot of IoT cloud platforms, you can create a service in Azure or AWS that would be custom and make the data available to a connector that ArcGIS Velocity can already work with. So for example, you could configure an Azure function to run in Azure, push data into the Azure Event Hub, and then ArcGIS Velocity could pick it up from there. And then more generally, ArcGIS GeoEvent Server has an SDK because it is technology that you can deploy on your own machines and manage extensions on. And so that you can always create custom connectors for ArcGIS GeoEvent Server. Another question was, can you use satellite photos? Is there a real-time satellite feed? There are real-time feeds out there that show satellite positions, and those types of feeds, I haven't tested with all of them. I'm sure some of them would be able to be ingested by ArcGIS Velocity. It does not process image or raster data at this time, however. Another question was, what kinds of advanced analytics or statistics can be run? In many ways, the advanced analytics are possible because of the way that you would combine the tools yourself. It's very much a visual programming interface where you can combine different tools together to compose an algorithm of your own. There are scripting capabilities built into it. For example, with a calculate fields tool, you can write arcade scripts to do more complicated and custom calculations on data. There's also, especially in the big data analytics, a variety of statistical tools. So there's the find hotspots capability, for example. Coming out in our April release, we're adding a tool to perform generalized linear regression so that you could model a dependent variable based on independent variables. Again, especially with historical data, this could be useful. There's also a tool called Find Similar Locations, which allows you to take in data and find other locations that match a set of training locations of interest, and that happens statistically as well. Another question was, has Velocity been used for wildlife telemetry data using transmitters attached to animals? And the answer is yes, it has. Not in a production capacity yet, but one of our early adopters was with a nonprofit, well, specifically a wildlife park in Africa, where there was testing and proof of concepts done with bringing in information from both stationary sensors in the park as well as sensors on I believe, elephants. Can Velocity be used for railroads to show live activity of train movements? Yes, it can. Velocity is fundamentally an appropriate solution to track any kind of moving entity, very much so. So one question that's come in is sort of about a comparison between different approaches, using ArcGIS technology, where if you have an ArcGIS server implementation, but you're limited in the number of records that you can access because of the processing power that's included in your ArcGIS Enterprise implementation. And the question is, would it make sense to host ArcGIS server within this environment to gain more processing power? And in some ways, the answer is yes. ArcGIS Velocity isn't itself a platform as a service, it's software as a service. So you couldn't literally take ArcGIS server and then run it inside of ArcGIS Velocity. But essentially ArcGIS Velocity acts as an ArcGIS server in many ways. So as opposed to running, for example, a geoprocessing service in ArcGIS server, you could run a big data analytic in ArcGIS Velocity, and that would take advantage of distributed cloud computing and be able to run certain types of jobs faster for that reason. Yeah. Let's see, what other questions do we have? One question that came in was about licensing. What are the levels? There's one of the things we can include out in some follow-up information, which is actually also available in our documentation. I'm coming back to our documentation slide briefly here, and it looks like it's displaying now for you guys. So the first link here, our documentation, has a section on our licensing that should have all the information that you're looking for. Fundamentally, there are 3 license levels that are tiered according to the data velocity that you need. So if you're bringing in information that is lower velocity and you're just monitoring 1 or 2 things, then there's sort of an entry level license level, and then it goes up from there. So I'll leave this up for a second in case anyone wants to capture any of these links now, but we can also share these out afterwards. One question was, can you describe the server-side technical requirements and where that server can exist? So for this one, I think there might be a little bit of a misunderstanding. ArcGIS Velocity it's software as a service, so there aren't any technical requirements to sort of be satisfied in terms of deploying ArcGIS Velocity on your own infrastructure yet. ArcGIS Velocity is not yet in a form where it could be deployed on your own infrastructure. So currently ArcGIS Velocity exists only in the cloud as part of ArcGIS Online. And there is a roadmap to be able to bring ArcGIS Velocity on premises. It is a Kubernetes-based architecture. So when it is supported in an on-premise environment, it would be running in a Kubernetes cluster in your architecture. And when we get closer to that point in our roadmap, that's probably the time at which we would be able to share more in the way of technical requirements. So one question that came in, a couple questions came in along these lines. Will ArcGIS Velocity replace GeoEvent Server eventually? And the answer is no. ArcGIS Velocity is a sibling product to GeoEvent Server in the cloud today because GeoEvent Server is not available as a SaaS today. And eventually we are also going to bring ArcGIS Velocity into an on-premise system, or be able to run it on premise. But even at that time, it's not a replacement for GeoEvent Server, and that's because ArcGIS Velocity is a Kubernetes-based system. It isn't software that can run on a single server, and we have many, many customers and organizations that need server-based software solutions. So ArcGIS Velocity and GeoEvent Server over time will sort of merge in terms of their look and feel and their capabilities. And that'll be part of the roadmap as opposed to any replacement of GeoEvent Server. So I think a follow-up question to the last one in terms of when ArcGIS Velocity is available for on-premises deployments, what would be the advantage of using ArcGIS Velocity over GeoEvent? And there's a lot of different reasons why you might choose one or the other. One is ease of administration. So when Velocity comes on-premise as a Kubernetes-based system, it will have many components, and you would fundamentally need a Kubernetes-trained staff to work with it, whereas GeoEvent Server is a single server solution. ArcGIS Velocity would also, in an on-premise deployment, be able to handle higher velocities and higher volumes of data than GeoEvent. But at the same time, GeoEvent also is somewhat more flexible than ArcGIS Velocity in terms of incoming data formats that can be accepted and then manipulated. So there are some differences there. So another question that came in, I think, from someone that's been taking a look at the documentation was about the appropriateness of the ArcGIS Velocity license levels for different organizations. So this is probably something that we would probably want to connect with folks in more detailed conversations on to sort of talk through their use cases and help organizations understand how to model their use cases in a tool like Velocity. One of the questions was, what is a use case? You know, what are 10 feeds? 10 feeds in ArcGIS Velocity would fundamentally be 10 different types of entities that you're monitoring. So one feed might be, in Kevin's demos today, the drone locations. Another feed that would be configured and run as a separate feed might be weather, for example, lightning strikes. Yet another feed might be reaching out to a threat data provider like Dataminr or Factal and bringing in data on threats from their APIs. So if you had multiple different real-time data streams that you wanted to take and potentially combine together in real time, that would be where you essentially have multiple feeds, and you might have more than one analytic being used to process that data. Okay. I think it sounds like maybe we've addressed the bulk of what's come in so far. So I wanted to thank everybody very, very much for their time, for attending today. We'll go ahead and close out here. And this webinar will be available later on for rewatching at will. So thank you very much, everyone.